Databases are the silent powerhouses behind virtually every digital interaction you experience. From checking your bank balance to scrolling through social media, databases make it all possible. But their story remains largely untold. The concept of organized data storage predates computers by centuries. Ancient civilizations created libraries and record-keeping systems that functioned as primitive databases. The Romans maintained extensive census records, while medieval merchants developed double-entry bookkeeping systems to track financial transactions. The modern database journey began in the 1960s with hierarchical systems like IBM's Information Management System. These early databases organized data in tree-like structures, reflecting the organizational hierarchies of the corporations that used them. They were revolutionary but inflexible by today's standards. A significant breakthrough came in 1970 when Edgar Codd published his paper on relational database theory while working at IBM. His mathematical model proposed organizing data in tables with rows and columns, with relationships between tables defined by shared values. This seemingly simple concept would transform how we store and access information. Surprisingly, IBM initially showed little interest in Codd's ideas. This hesitation allowed others to advance the technology. In 1979, Oracle released the first commercially available relational database management system, beating IBM to market by 2 years. The 1980s saw the rise of structured query language, or SQL, which became the standard language for database interactions. SQL democratized data access, allowing non-specialists to retrieve and manipulate information using relatively simple commands. Behind the scenes, database systems were becoming increasingly sophisticated. Query optimizers analyzed requests to determine the most efficient execution path. Transaction management ensured data consistency even when multiple users accessed the same information simultaneously. These invisible innovations made databases both more powerful and more reliable. The Internet era brought new challenges. Web applications needed to handle unprecedented volumes of users and data. This led to the development of NoSQL databases in the early 2000s, which sacrificed some traditional database features for scalability and flexibility. Meanwhile, specialized database types emerged for specific needs. Graph databases excelled at mapping complex relationships. Time series databases efficiently stored chronological data. Column-oriented databases optimized analytical processing. The monolithic database gave way to purpose-built systems. Cloud computing transformed database economics and accessibility. Database-as-a-service offerings eliminated the need for organizations to maintain their own database infrastructure. This democratized access to enterprise-grade data storage for startups and small businesses. The big data revolution further expanded database capabilities. Systems like Hadoop and later technologies enabled the processing of petabytes of information across distributed systems. Data that would have been discarded as too voluminous to analyze became valuable business intelligence. Today, databases are evolving to meet artificial intelligence needs. Vector databases store and retrieve data based on semantic similarity rather than exact matches. This enables applications like image recognition and natural language processing to find information based on meaning rather than keywords. Privacy and security concerns have driven innovations in encryption and access control. Homomorphic encryption allows computations on encrypted data without decryption. Zero-knowledge proofs verify information without revealing the underlying data. These technologies balance utility with confidentiality. The environmental impact of data storage has become increasingly important. Modern database systems incorporate energy-efficient algorithms and hardware. Some even use predictive models to move rarely accessed data to lower power storage tiers. Databases have evolved from simple record-keeping systems to sophisticated platforms that enable artificial intelligence, real-time analytics, and global-scale applications. Their untold story is one of continuous innovation in response to changing needs and technologies. The next chapter in database evolution is being written now, with systems that self-optimize, self-heal, and adapt to changing workloads without human intervention. As our digital world grows more complex, the humble database continues its quiet revolution, powering possibilities we have yet to imagine.